Let me now reintroduce Goksel Dedeoglu of PercepTonic. Most of you met Goksel this morning when he introduced the technical program. Goksel is our program chair for the Embedded Vision Summit today. He's also the founder and lab director of PercepTonic. Before that, he spent 7 years with Texas Instruments doing vision research and development. And before that, earned his Ph.D. at Carnegie Mellon. Goksel is really an authority on both the sort of fundamental algorithmic and research aspects of vision, as well as the practical implementation aspects of embedded vision. So we're very fortunate to have him talking with us today about Lucas-Kanade tracking, what it is, how it works, and how to implement it efficiently. Please welcome Goksel.
Thank you, Jeff. Thank you. Well, thank you very much for being here this afternoon. I'm happy to get you initiated to the topic of Lucas-Kanade tracker with this tutorial. I should start by acknowledging first where this work has been done. So the particular tutorial I'm going to be presenting and the demos were actually produced by myself and Andrew Miller back when we were with TI. And we have since sort of gone our own ways, and Andrew had his own startup company, finishing his PhD. And as Jeff mentioned, I started PercepTonic. So before jumping into Lucas-Kanade, I think it's a good idea to take a step back and think about what role Lucas-Kanade tracking is going to be serving. So in the big scheme of things, I think the concept is motion, understanding motion, sensing it, quantifying it. And that's because the community has already figured out that motion gives a lot of useful information. We have already embedded motion-based inference information into all kinds of products. For example, in automotive, you can imagine the automotive is moving itself, so it's critical for it to understand how it is moving on a given road or how other objects are moving in the scene. Let's say a pedestrian walking in front of the car or just cross traffic. In video security, motion has been sort of the fundamental, the focus point for a very long time. You can analyze a given scene. You can analyze the traffic patterns, which is motion patterns in that scene, to infer things like panic situations, maybe undesirable situations, or even like a traffic jam. And if you just look under the hood of many human-device interactions, a lot of them are using concepts of analyzing motion information. First, extracting motion, establishing, measuring it, and then building on top of it to enable things like different gestures. What does it mean to be doing different gestures with different sort of parts of the body? Let it be the human face, different expressions, or hands. Now, obviously, cameras are not the only way of getting motion information. So I definitely want to acknowledge the inertial sensors, range sensors, even GPS. But this particular talk is going to purely spend basically the bulk of the time on image-based motion analysis. And as you go from one application to the other, the specifics and requirements of the motion information is going to be different. Some of them are going to want 2D motion. The others might be just requiring 3D, resolution, accuracy. All those requirements are going to be application specific. So I would like you to have this mindset when you look at any motion understanding algorithm. Actually, it doesn't have to be just Lucas-Kanade. Any tracker out there is sort of a point in this large space of motion understanding.